Alright, so let's take this diagram here of two guys tugging on a rope, and the question says, consider the situation above, where two people are pulling on a rope an equal distance of 10 meters from their favorite cup at the origin. After pulling for a while, the guy with mass 90 kilograms moves 6 meters towards the cup. How far and in what direction does the guy with mass 2 go? To start, we can use the center of mass to solve the question. The position of the center of mass formula is given by this, where xcm is the center of mass of the system, xi is the position of mass I, and then mi is going to be the mass of object I in the system. And in this question, there are two objects, so I equals 2. So we have the mass A, which is the person 1, and then mass B, which is person 2. And I just want to know that the rope is assumed massless, so it does not contribute to the center of mass. So if we plug in I equal to A and B into the equation for the center of mass, we get this. And one thing to note is the center of mass will be constant throughout the motion. After the displacement, when the guy gets pushed forward 6 meters, the center of mass is going to remain constant at the same spot, since the ratios will be the same before and after. And this has to do with the conservation of momentum holding. We know that conservation of momentum holds in this situation because we can assume that the net external force is constant. So this is the necessary condition for the conservation of momentum to hold. And so we can apply this to our example. So if we use our center of mass equation, we can identify that the position xa is going to be negative 10 meters. This is the position of the guy A. And then xb is going to be equal to positive 10 meters. This is the position of guy B. And then we can also plug in the mass of A and the mass of B. And if we do that, we get this expression here. Compute the amplitudes in the units of this expression. We get that the answer is negative 2 meters. So this is the center of mass of the system. So after the displacement, the position of guy A goes 6 meters towards the mug at the center. So if we draw a diagram here, we can see that 6 meters to the right for guy A, he's going to be ending up at negative 4 meters. So we can identify that the center of mass is still going to be negative 2 meters in this situation. Now this center of mass position will remain constant, and so we can apply our center of mass equation again, noting that we need to find the new xb position. We can just plug in the new position of the guy A as well as the other known variables with the constant center of mass position. Do that and we can isolate for new position of xb. If we perform the necessary operations and compute, we find that the final position of xb is going to be 1 meter. So this is the final position of the second guy after the first guy displaces 6 meters. If we look at our diagram here, the guys start 10 meters away from the mug at the origin. Guy A displaces 6 meters to the right, ending up at negative 4 meters. We just found that guy B actually ends up at 2 meters. So he has an 8 meter change. Notice that the guy with mass A is actually closer to the cup than the guy with mass B. And this makes sense because the center of mass is constant and mass A is lighter than mass B. This means that the lighter guy will displace a larger distance due to the force being applied pulling the same rope from opposite sides. And this is because in order for the center of mass position to hold at the same spot, the ratios between the masses need to be the same relative to the positions. And that's why he displaces more distance than guy A.